Hi, welcome to the Introstat lecture series. And we are doing this unit's testing hypothesis unit. This is our lecture number 3. We're going to talk about type 1 and type 2 errors associated with the testing hypothesis. And we're going to divide this lecture to maybe 2 or 3 different videos to cover the important concept here. And so the first part we're going to talk about is the significant level and the critical values. What are those things and what they means here? Okay, so before we even start, let's go back to revisit our lecture number 2 when we talk about a null hypothesis, alternative hypothesis, and the p-value, because they're all related together. So let's just go ahead and do a very brief reviews. So then we'll be able to kind of continue here. So from the lecture number 2, right? So we say we have 2 kinds of the hypothesis. We have a null hypothesis, we have a alternative hypothesis, right? So you can test like almost like you can test a lot of different situations, right? So like, for example, we are testing. So let's take a look if we want to test a proportion or percent. So if we are curious to see the dollars, what is the percent of the smokers, right? So what you can do, you can say, okay, I can test the P, that means the percent of the smoker. I will say, hey, people say we have a pointer 37. That means 37%. So as a researcher, you can say, I don't think it's a 0.37, but I'm not sure it's bigger than 0.37 or smaller than 0.37, right? So you can say, I said, hey, it's not equal to 0.37. It's not equal to 37%. So, or you can say the people said, okay, the dollars, the smoker is 37. Then you say, I think is that there are way more people smoke. I think the percent is greater than 0.37 here. And then you can also say, hey, you know, I think it's less than 0.37 because in recent years, we have a lot of commercial, a lot of advertisement to tell you how bad is smoking, right? So you say, okay, maybe it's less than 0.37. That means less than 37%. So those are the typical, we have a null hypothesis, alternative hypothesis. Remember, the alternative hypothesis, what do we call it here? This we call it is research hypothesis, right? That means that's the reason why we were doing this experiment, that we want to prove it. So if it's not equal, so if you still remember, we said this is a two-sided test, right? So it's a two-sided test. You test either bigger or smaller. If it's greater than, this is the one-side test. Because this is greater than, we say this is the right side, right? Okay. And then if it's less than, then we will say this is also is a one-side test. And then this we say this is the left side, right? So then after that, from the previous lecture, we also talk about is after this, you're going to collect some data, right? So that's the kind of the first thing to define your hypothesis, and then you're going to collect some data. Then we talk about one very, very important concept. We call it the p-values here, right? So p-values, this is the, a lot of people specifically, when we talk about the proportion test, a lot of people get confused this p-value with these proportions with percent we try to test. They are different, right? So here we just try to test the percent of smoker equal to 37%. But the p-value is a number, is a probability associated with your statistics, right? So when, what is the probability of the statistic, that statistic will happen here. Like one of the example I was showing you, I'll say, hey, this person, if I'm thinking about this person is guilty or not guilty, right? So here we say, okay, I want to prove this person is guilty, or I want to prove this person is not guilty here. Okay, so like the example I gave you, say if we find a DNA match, right? So if we find a DNA match, this is my data, right? So I go to collect the data. I find the DNA match for this person. I find the DNA evidence in the crime scene, and the suspect, I have the DNA match. So we know if two people totally unrelated, they have the same DNA, the probability is less than 1 in a million or 1 in a 10 millions, right? So if you say, that's why we said, if you say this is not guilty and you got a match, it's possible? Yes, it is possible, but it's very, very small, right? It's less than 1 in a million, 1 in a 10 millions, right? So it could, but most likely this person is guilty here, because the chance for this to happen, if the under the null hypothesis is true, is so small, then we know probably this person is guilty. So that's why we want to kind of reject the H0s here, right? That's what is the one of the key concepts we want to, the reviews before we started this, this topics here, this lecture. Okay, so let's go to our lecture notes here, okay? So for lecture notes, we say, let's try to do the revisit of the p-values. Here we just did that, right? So we said here, so what is the p-values here? So we say the p-values here. Okay, so the p-value, so I need to be careful here. So a p-value is the probability, right? So it's under the conditions, right? So here, be very careful here. That's what just we talked about before. Is given that null hypothesis is true, and the probability you will find that statistics, like the example I give you, null hypothesis is this person is not guilty, right? Then the observed statistic is your match DNA. If this person is not guilty and you get a match, that probability is very, very small. That's what we call it, the p-values here, okay? So that's why we said that's the one main things we did from the last lecture. We say if for the p-value, right, so is small, right? So what you do here, you can, so basically I'm going to reject my null hypothesis here, okay? So however, of course, right? So if you p-value, so like in here is the always, okay, so let's take a look here. So like in here, you said, all right, so that means, when we see a very small p-values, right? That's what we said. When you see a very small p-value, you can continue to believe the null hypothesis. Okay, and then you can conclude we just witnessed a very rare events here. Okay, so it's just like we talk about here. You said, you can say, hey, for the DNA match layers, right? I said, well, that's just like very, very rare. It happens. Okay, so that's why we said you still can say the null hypothesis conclude we just witnessed a very, very rare event, but instead we trust the data. Oh, well, or you can say, well, I trust the data, so I'm going to reject null hypothesis, just like in here, we say we reject null hypothesis here. Okay, so that's what is the p-values here. And then also we talk about how about, the p-value is big here. Okay, so here, let's see here. So That's why we said, however, if you find a big p-values here, right? So if you find the big p-values here, so what's that mean? That means what you see is not surprising, okay? So that means the results are now in line with our assumption that the null hypothesis model, the word, so we have no reason to reject it, right? So like the example I gave you, like the last lecture, we said this person is guilty or not guilty, right? We use this example a lot. I think this is kind of easy to, right? So like if your evidence or if your statistic is a match hair, right? So it's a match hair. If the hair, you say, hey, I find a black hair. Now, what is the chance for the random hair drop, you will see a black hair? Probably it's pretty high, right? So if you see a black hairs there, so what happens here? So it's not surprising. So you cannot say, oh, I reject H0. So it's he could be not guilty and we just match hair, but because the chance for black hair occurred is very, very common, right? So it's not surprising here. So that's why we have no reason to reject it, correct? Okay, so now, okay, so let's take a look at this one here. So the next statement here, we will say here. So, oh, sorry, here I already got this, so we don't have no reason I double that. Okay, so now let's, so here, this is my last statement here. Okay, so this is a kind of importance here when we try to write the conclusions here, okay? So if you see large values, right? So that means if you see a large value, p-values here, so that means, you cannot reject it. So that means it is not, it's happen commonly. So that's why we typically use the word, we don't reject null hypothesis here. The reason why, the reason why we don't use the word, we accept a null hypothesis. So no, we don't do that, right? The reason why is because as a researcher, or, you are the DA try to try this person, your main job is here is what? You want to establish this part, right? So if I'm the researcher, remember that's what we call it a researcher hypothesis. That's the one I'm interested. And now, because I find a hair match here, I cannot claim, oh, because a hair match, the black hair is very common, so I can accept he's not guilty. So the only thing I can say is I don't reject the null hypothesis. That means I'm not say he's not guilty. I just cannot say he's guilty, right? I'm not accepting. I just don't have, I just don't have enough evidence to say this person is guilty here. All right, so that's why the wording is extremely important, right? When you do the testing hypothesis here. So if you have a big p-values here, then you said, I'm not, reject a null hypothesis, or you say I fail to reject a null hypothesis because of the evidence. Because of my goals here, I'm really trying to establish what is my research hypothesis, right? So I never really want to accept a null hypothesis. I just say whatever the data I collect, I don't have enough evidence to support what I want to establish. So that's why I fail to reject the null hypothesis here. Okay, so this is a part of what we did, from the last one. So let's be careful. That's what is the p-value, right? So the things here, the p-value is the probability that statistic happen when the null hypothesis is true, right? Just like we say, if you find the DNA in the crime scene, and if this suspect is really innocent, but you have a matched DNA, the chance is very, very small. And so my data provide me enough evidence. I can reject the null hypothesis here. Or you can say, I still don't want to reject the null hypothesis. I just say I witness a very rare event, right? So because this event is so difficult to occur and it occurred, so your data does provide very good evidence to support what you want to establish. That is alternative hypothesis here. Okay, clear? So we talk about the p-value again. Okay, so now what is the significant value level and the alpha values here, right? So a while ago we talked about the p-value, right? So after this, you should remember one thing here. What do we want? We said the smaller the p-value, right? What is here? The stronger what? Evidence to reject H0, right? So we say the smaller p-value give me the stronger evidence to reject the null hypothesis. Then you will ask me, okay, how small is small? Is 1 in a million is small, or 1 in 10 millions is small? So how small is small? And also your small could be different than my small, right? So I hope that, as we make the decisions, we can we have the same standard to compare. And so if we can agree, say, hey, if the p-value is less than a certain number, then we all agree we have a strong evidence to reject H0s here, right? So how small is small here, right? So that's why we said we want to set a threshold, okay? So we want to set a threshold here. So that's why the threshold we called is the alpha values here. Okay, so you will see, you use this is very important, right? You will use the notation. We call it this is alpha value. And we're going to see this alpha value have another terms later, right? So that means this is the alpha value. So we say, hey, when we below these values here, then we will say, I have a strong evidence here, okay? And also the alpha values, the alpha level, also this one is also called significance level. Okay, so that means, how, so you will see what is this alpha value. That means our next video, we're going to talk about what do we call this alpha value is, we call it the different type of the errors, right? Type 1, type 2 error. So, but here, let's take here. So alpha value is the threshold. That means if your p-value is less than that, then we say, it's a very strong evidence. See here. So what are the common alpha values here? Okay. So in the statistic area, so most of the research, like a paper or the publication you review, so those are the most commonly levels here. So what are the level? We have 0.1, 0.05, and 0.01, see here. So that means those are the three most, most commonly used. So when you read the statistical report or publication, so frequently they will say my significant level is 0.1, 0.05, and 0.01. Among these three, 0.05 is the most commonly, the even common is the most commonly used in the 0.1, the 0.01. And sometimes if you do not see people specifically write out the significance level, so in general, we will kind of treat as the rule of the thumb, we will say is 0.05. So it's a, okay, so it's a 5%, right? So it's 0.05. So that means when the p-value less than those values, then we will say, hey, my data, I provided the strong evidence here, okay? So to reject the null hypothesis here, right? So how do we say those things? When you write, when you do the statistic, when you write the statistical report, right? So you will say here, okay? So here, this is what you're going to say when you write the conclusions here. So let me see here, oops. Okay, so here, okay, so here, okay, so, okay, so you will say, so if you have p-value, okay, so this is how do we report in our, so if your p-value less than your alpha value, okay, then what you say here, so you will say the data have failed. Oh, I'm sorry. So if your p-value is greater than here, right? So if your p-value is big enough, so it's here is greater than. So that means here, if your p-value is greater than your alpha values here, right? And so you will say your data fail to provide sufficient evidence to reject null hypothesis at that level, right? At what? At the, so here, at the significance level, at like you can say 0.05 significance levels, right? Okay, so that's how do you write the statement. So you should say the data failed to provide sufficient evidence to reject the hypothesis at the 0.05 significance level or at the 0.1 significance levels, right? So it depends how do you, which level you use. Like we talked before here, do not say, right? So do not say I accept null hypothesis. All right, so we don't use the word accept here. So you say you fail to provide sufficient evidence. Okay, so don't ever say you accept it. Okay, and okay, so what is the, you know, the good and the baddest about the significance level and the alpha levels, right? So in here, you know, the alpha levels here, so the alpha value, with different people still can choose different values, right? So some people will choose 0.1, some people choose 0.05, and some people choose 0.01. Or if you like, you can choose 0.02. So you can choose any levels you want, right? So when you read the, you know, when you read the statistical reports, like we say, some people give you the different levels, but, you know, the p-value you provide only have what? Only have one value for your test, whatever depends on whatever you test, right? So the p-value, you only have one value here. Okay, so it doesn't matter because if I do the test, right? So if, you know, like if John choose the 0.05 and if Mary choose the 0.01 here, all right? So then your p-value, so if you just look at that, then sometimes you will say, hey, I'm going to reject at the 0.05, you know, accept it, fail to reject the 0.05, but reject the null hypothesis 0.01. And so depends, right? So if the John, if this is the John's here, right? So if this is the Mary's here, if your p-values, let's say if your p-values here is 0.03, right? So if your p-value is 0.03, right? Okay, so if it's a p.03, so John will say what? John going to what? The p-value less than John going to reject, right? Then what happens here? For Mary's here, Mary's fail to reject, right? So if you only give the significance level or the alpha values and without providing the p-value, you probably do not get a good ideas like, you know, why here, right? So like, so why the same data John reject and Mary, you know, fail to reject. And so that's why, you know, for the even for the alpha, you still sometimes you cause the confusions because you know, we only have one p-values. So the best is, you know, you provide a p-value, then provided your significance levels here, okay? And now the next thing here is we're going to talk about is the critical values. Okay, so all these are the terminologies here. We need to be very careful, right? So what is the critical values here, right? You know, the p-value, we say, hey, p-value is good. Right, so p-value is good. It's a good one single value, you be able to make the decision because only single value, you know, value. So like 0.001, 0.35, 0.12, right? So it's one single value. Then you can compare to the whatever the significance level you want to do. And so that's easy. But p-value has a province here. What is the problem? So it's difficult to find. Without software support. So you have statistics, you have a test statistic, but you want to find the p-value in general is difficult to find if you don't have the software. Right, so especially, you know, the different p-value associated with the different, you know, the probabilities. And so instead of using the probability to compare to the probability, right? So instead of using p-value to compare to the, you know, your alpha value, then we will compare test statistic to what? To what we call is the critical value. Okay, so because the p-value is difficult, why the p-value is difficult? Why is the p-value is difficult to find? Because the p-value is difficult is because of what? The p-value is depends on the distribution of your test statistics. And those distributions is not easy, right? So those distribution is not easy to find. That's why we said you have to have software support. Without the software support, the p-value might not be easy. And you know, for this method, since we're going to learn, you should be able to, you know, find. So like if you use the, you know, if you use the calculator TI-84 calculators here, and it will provide you the p-value. But in general, if without those graphing calculator or without the software, the p-value is not easy. So this is what we're going to find the critical values, right? Okay, so now the one thing here, what is the critical value? Okay, so the critical value Okay, so the critical values here, right? This is the value corresponding to your alpha value. Okay, and okay, so and have underlying distributions assumptions. So it depends on what is your distributions here, right? So that's, like I said, that's the part is difficult, is this distribution assumption. So for different distribution, your critical values will be different here, okay? So let me give you the first, the very common one. So the most common one, we're going to use this critical values here. This most common one is depend on the normal distribution. So what is the normal distribution? We're going to talk about in our next lectures, right? So that before we physically do any test, so we're going to talk about what is normal distributions here. So this is the most commonly used. So I'm going to give you a tables here. So this one's here, remember this is alpha values, right? So we know the critical value corresponding to the alpha values here. You see that corresponding to the alpha values and have the underlying distribution assumptions here. So for here, I'm assuming it's normal distribution. And we're going to go way more details in our next lecture number. I think lecture number part 3 or part 4 for, for this ones here. After we talk about the different type of the arrows, we're going to talk about what is normal distributions here, all right? So here for the alphas here, right? So we talk about the 3 most common ones. So it's 0.05, right? And the 0.01 and the pointer. Okay, so 001. Okay, so here they want to use the pointer 001. So let's do here. I think the 0.001, let's do here. It's a 0.1. Okay. This is the 0.1 here. Okay, so now we talk about one side, 2 sides here, right? So one side test and a 2 side. Okay, so for the 2 side tests here, I know here maybe this one's here. So for 2 side, remember when we review the smoker is 37%, right? So if you don't believe it's 37%. So for example, if this is 37%, if you say, hey, I don't believe it's 37%, what means you don't believe? That means it could be what? Could be bigger or could be smaller, right? So here, right? So that's what we say is a 2-side test. So when you, whatever you calculate your test statistics here, right? So now because of that, so we use the normal distributions. So here, this one will be the zeros here. So that means this is what I call this the critical values here. And so if for the 0.05, right? So I'm talking about the 0.05 here. That means each one's here, this is 0.025. This one's here is 0.025. What is the critical values means? Critical value here, this means 1.96, and then this is negative 1.96, right? So in here, the 2 side we say is plus minus 1.96 here. All right. Then what is the one side test, right? So when we one side, we say, hey, for the 0.37, right? Then I can say it's greater than 0.837. That means greater than, that means I'm only looking for here. I'm interested only in here. This is greater than, right? This is one side. And so this one here, this is 0.05, right? That's what we say is a threshold is 0.05. So then in here, if it's greater than, it's over here, right? So then the critical values here is 1.645, okay? So you will have 1.645, and I'm going to use the, if you say this is less than, right? So this is less than 37%. So what happens here? You are going to have here, right? So this is 0.05. So what is here? So this is negative 1.645. So this will be plus and minus. Okay, so let me see here, okay. So this is minus 1.645. I'm going to color code that so you will know, so we're not confused here. So the yellow will be right-hand side, all right? And negative going to be left-hand side here, right? So this is the critical values. And after we talk about the chapter about the normal distribution, then this table will make sense. Right now, I'm just going to write it out to get an idea. So for the true side, if you say it's not equal to the 37%, so could it be greater than, could it be less than? But see here, the areas like the exceed your critical value, you know, two sides, when you add these two together is what? 0.05. One side is 0.05, this side is 0.05. Okay, so for the 0.01, that means what? That means these areas here, instead of 0.05, is 0.01 here, right? Okay, so now in here, the 0.01, so for the one side here, this is a 2.33 here, all right? And then for the two side, this is a 2.576, all right? Okay, so remember that is, we find is the area is 0.01 here, okay? Okay, so that's why I use the different color, right? So still, if it's right-hand side is positive, left-hand side is negatives, right? So let's try to color code that so we know exactly what we mean here. Okay, so now for the 0.1, I'm going to use the different colors. So the 0.1s here, right? So for the two sides here, it will be 1.645. Then the one side here will be 1.28 and the negative 1.28. And the same things here. This is the right-hand side and this is left hand side. All right, so like in here, okay, so just for example, like the 0.01, that means the same things, right? So like I use the color here. So if it's one side, so this one here is a 0.01, right? So for the true side, did you see the color coding here? Okay, so for the true side here, I have here, right? So this will be 0.005. This is 0.005, right? Okay, so that's what we mean, the critical value. So now, instead of compare the p-value, you're going to have statistics, right? So you're going to compare the test statistics here, all right? So that's what to the critical value. So because that we said the p-value is difficult to find, but the test statistics here, you know, you're going to compare the test statistic to the critical values here, okay? right? All right, so now I know this is a lot, and now I like to go back here. I want to do a very simple summaries here, right? So how do you make so alpha values, right? So alpha value, this is, we call it is the alpha. That's the threshold, right? So those are the threshold for the P, right? So in here, so the P value, you compare to what? Compare to alpha values, right? So if you calculate the p-value, you compare to the alpha value. If you know how to calculate the p-value, like we said, it's very difficult. So if the p-values here, right? So we say if the p-value is less than alpha, then what do? You reject H0s, right? If the p-value greater than alpha, do we say accept? No, we say fail to reject. Okay, now this is the alpha value. Alpha value is also significance level. Okay, so now we talk about the critical value. Okay, so the critical value we know is for each alpha value. Okay, we have a critical value. Right, so critical value is associated with the alpha value, just like that table I did for you a while ago, right? So what do you compare? Instead of compare the p-value, you compare your test statistics value to the compare to the critical value. Right? So that's what you do here. All right. So you will ask, what is the test statistic value? I'm going to show you in our future lectures here. So we're going to give you so many different formula. So for different testing, you have different test statistics values here. So when do we reject? If the test statistics, right? So for example, if you have two, right? So if this is a two-sided test, right? So if your test statistic is sitting over here, then this is fail to what? Fail to reject. Okay, so sometimes we call the loss values here, the tail value, this is, we call this a rejection regions here. If your test statistic fall into the rejection regions, then you will what? You will reject. So those values here, those values here, those blue one, this is, we call this critical values here. I give you the table. Some of you might, those table doesn't make sense right now, but later you will see that, right? So if for the one tail, you know your rejection region could be here, or you know your rejection region could be here, right? So if your in here is outside the rejections, right? So this is, we say, is a fail to reject. So this pink one is, what is this pink one? This is your test statistic value. All right, so, and what is this green, what is this blue ones here? Blue one, this number, this is your criticals, right? Like I would say that this critical value depends on the what? Depends on the assumption of your what? Assumption of your, you know, your test statistics, right? So the same way is here, let's do one up here. So if this one is your test statistics sit over here, then what do? We reject H0s, right? Reject null because I'm in the rejection region. And so what is this value again? This value is a critical value again, right? Okay, so we talk about the two very, very simple concepts. Alpha value, so you do the p-value compared to the alpha value, or you do, if a p-value is difficult to find, right? So you find the critical value, then you do what? You do the test statistic versus the critical value. So you have two things, right? So the reason why we want to talk about the critical value is p-value is what? Difficult to find. Right? So without the software support, the p-value is difficult to find. So, that's why I'm going to use the critical value, okay? So this video, we're going to talk, that's the two key concepts we talk about, is the alpha value, the relation of the alpha value with the p-value. If the p-value is difficult to find, then I'm going to find the critical value. Critical value is based on based on your alpha values here, and also you have the distribution assumptions here, right? So you'll be able to find the critical value, like the example I gave you in the lecture note, that table is just an example. We use the normal distribution. You can use the t distribution, you can use the chi-square distribution, you can use the f distributions, right? So you can have the different the distribution, and you have different critical values. That's it. So these are two concepts in this lectures. This is part 1 for the lecture number 3 here. All right, that's it. I hope you got a good understanding for this, because we're going to next things here. We're going to talk about is the different arrows, type 1, type 2 arrows, and it's kind of like related to your alpha values here. All right, that's it. Have a good day, and we'll talk to you next videos. Okay, bye.